Alright, so we've done lines, we've done inequalities. Now we're going to move on to domain and range, something you guys have done a lot of. So just to recap, a domain are the possible x values that you can plug in into a function. So in other words, in order to be part of the domain, you have to be able to plug it in and get something out. And that something you get out is the range. So your range is the possible y values that can come out of a function. So x's are the numbers we can plug in, y's are the numbers that come out after we've plugged in the x's. So there's some things, certain types of equations that limit our domain. And so when we think about the types of things that can limit our domain, so we're wanting to think about the types of equations that'll give us a does not exist. And so when I think about what kind of equations give me a do not exist, so what kind of equations give us undefined, otherwise known as the null set or no solution? One of the first ones that comes to mind for me is when x is in the denominator. Because what number can never be in the denominator? X cannot equal 0. That right there is a limitation on our domain. A second type that comes to mind is a square root function. Can we have a negative inside of a square root and get a real number answer? We can get imaginary, but we can't have negatives. So what we would have to do is set it up so that negative x has to be greater than 0. Whatever is underneath has to be bigger than 0. So what we're going to be looking at today is these limitations that we could potentially have on our domain, and then finding our domain with those limitations. So we're going to start with finding the domain. And we're going to be looking for situations where we might have a restriction on our domain, and when we do, we'll have to figure out what that restriction is and then eliminate it from our answer. So if we look at our first one, f of x equals 7x minus 5. So the first thing we want to think about is, what is our graph going to look like, or what would the what kind of equation is this? So this is a linear equation because the highest power is 1. So something we know about lines, we graph a y-intercept and a slope of 7 over 1. And when we connect the dots, are we ever going to have like an open circle or an undefined piece? No. Polynomial functions that don't have fractions, which makes them polynomial functions, tend to have no restrictions on your domain. So we would just say it's from negative infinity to infinity. Because this goes on forever, we're going to hit every x in the positive, every x in the negative, and never have an issue with that. For this next one, Again, I'm going to start by what kind of equation do I have? So I'm thinking, do I have either of my two cases where I could possibly restrict my domain? So in looking at this, I see I have a quadratic. Quadratic's a U shape. So if I were to try to roughly sketch this, let's see, I know I'm going to have a y-intercept at 2. So it's going to be somewhere like this. It's positive, has a y-intercept at 2, it's something like this. So that, and again, I don't have any point that I won't hit. All my x's are going to get hit as it continues to grow. So again, negative infinity to infinity. So here we're just talking domain. If we were talking range, will I hit all the y values on our graph? No, I'm not going to hit any y values below 2. So for the range, we would say from, no, we'll hit negative 2, or we'll hit 2, but we're going to go up to infinity, so we won't hit anything below that. So depending on the question, domain or range, you might, as a quick sketch might help, but it's not necessary. Okay, let's look at this next one. So when I look at our equation, again, I notice it's a polynomial equation, specifically another quadratic. But there's something a little different about this one, and that's this piece right here. X cannot equal 5. So that right there, that's a domain restriction. So that means when I go and write my interval notation for what my domain is, I'd have to say everything except for this value here. So we can sketch it again. It's the same one as this, just plus 3 instead of minus 3. So I'm going to have a little sketch. But at this point where x is 5, I have to have an open circle because it can't equal that. So when we go to write our domain, we'll be able to go all of our x's from negative infinity up to 5, but don't include 5, in union with 5 all the way to infinity. So here we're gathering all of our potential x values, but excluding the one that doesn't fit. Okay. This next one, I want to do f of x equals x plus 5 over x minus 3. So here we have a fraction. So it's not a polynomial function. So that means we can't assume it's negative infinity to infinity. We have to check for a potential restriction. Now, unlike number 3 where it told us a restriction, this one we have to kind of go back here. We know that our denominator cannot equal 0. So how do we find the restriction in this fraction? By taking our denominator, x minus 3, and we set it equal to 0, and solve. That's what x cannot equal. So I know that my domain is going to be every x value from negative infinity all the way up to 3, but not 3, in union with 3 all the way to infinity. But again, using parentheses to make sure that we're not including that 3 in our domain. Okay, I'm going to do one more, maybe 2. At least one more here, and then I have a couple more that I want to do with you in class, particularly one that's going to be on the test, or like one on the test. So this next one, f of x equals the square root of x minus 7. So again, when we have a radical, a square root, or anytime this is even, this, what's inside our radicand, has to be greater than 0. Otherwise, we'll get an imaginary number. So to find our domain, we're going to take our term inside and set it greater than 0 and solve the inequality. So this, our domain, is going to be all the x's greater than 7. It can equal 7 because we can have 0. We just can't be less than 0. So here we would say a square bracket 7 all the way to infinity as our domain. Okay, this will be the last one. So on this last one, if you look at, it's a similar problem to number 5. I don't know why I wrote 8. It's supposed to be number 6. It's still a radical, but the difference is our index. Here the index is odd. Well, when we have an odd index, can we have negatives inside of our radical? Yes. So it's only with the even index, so square root, there's that imaginary 2. The even index has to be greater than or equal to 0. The odd index does not have that restriction. So this would be just like a polynomial function, a domain where x can be anything. There's nothing restricting it because we don't have that negative. So I have a couple more. I have another one like number 5, but where we have a quadratic, so we'll have to do a little bit of quadratic inequality as well. And then I also have a couple more if we need it that are like number 5, as well as another polynomial one like 1, 2, and 3. So we have a few that we can do in class if needed. For sure I'm going to do the inequality with a quadratic, just because that's the one that's similar to a test question. But if you have any questions or need clarifications on any that we've done so far, please come with your questions so we can go over them.